Tomorrow we are going to begin working on finding volume with fractions. Finding volume is a skill that we will be reviewing. Adding the fraction component is a part of our 6th grade standards. So our first key point, volume is the amount of cubes that can fit into a 3D object. We can simplify 2 or 3 fractions being multiplied by dividing cross products by common factors. Some examples could include something like this. 2/3 times 5/2. We can cross cancel to simplify our fractions before we multiply them. We can find 2 pieces that can be cross-cancelled. So we can take 2 out of both of those, leaving 1. And ultimately that will lead us to 5/3. This makes it a lot easier when we are working with volume, because if we did not cross-cancel, then we would end up with numerators and denominators that would enter the 3 digits. So this is going to keep things simple for us. Now, how to find volume with fractions? We multiply length by width by height. Cross-cancel until all cross products have no common factors before you multiply. And simplify if possible. If we effectively cross-cancel all the cross products, then we will not need to simplify in the end. Now looking here, we're going to set this up. We have 3 centimeters by 3 5/5 centimeters and 4 3/3 centimeters. 3 times 3/5 times 4/3. Now, I need to remember that a whole number can always be written with the denominator of 1. Now when I'm cross-canceling, I have a choice. I can cross-cancel anything that has the same factor, so we have a factor of 3 here and here. I can cancel these. I can also cancel these. However, I can only cancel them in pairs. And once I have canceled as part of a pair, I cannot repeat that again. So I'm going to go ahead and cancel here 3 and 3, which leaves me with 1 and 1. Now this is a lot easier to do. I know that 1 times anything is the number itself. So all of those are going to end up being 1 times 5 times 1, which gives me 5, which gives me 5. So I have a denominator of 5. 1 times 3 gives me 3. 3 times 4 gives me 12. So the volume of this rectangular prism is going to be 12 and 5 centimeters cubed. This is how we report, like it noted here, how many cubes would fill into a 3D object. This has 3 measurements, so it is a cubed unit. Now we have a square prism, has sides that are 5 inches long. The prism is 7 3/4 of an inch tall. What is the volume of the prism? To help me visualize this, I am going to go ahead and draw a model. Now I know a square prism has an end that is a square. This is not a very good square, but pretend it is. This is an example of a rectangular prism. We have a rectangular end. This is a square prism. So I'm going to go ahead and make the sides. The sides of the prism, or rather the length, is not the same as the height and the width. This is the square end, and this is a square end. Now I'm going to label these. It says the square prism has sides that are 5 inches long. So I know this is 5 inches, and because squares have all sides measure the same, I know this is also 5 inches. Now, and in this case it says it is tall, so I should have probably drawn this standing up but that's okay. That's not what I did here. The prism's measurements are still the same. So we have here 7 3/4 inches. Now what is the volume of the prism? What I need to do now is set these up to multiply. However, I notice here that I have a mixed number. I want to turn this into an improper fraction first. So we have 7 3/4. I know that when I have a whole number, I can multiply that by the denominator, which gives me 7 times 4 equals 28, and then add that to the numerator. So 28 plus 3 equals 31. Now my improper fraction then becomes, and I'll do a little arrow here, 31/4. Now again, I did that by multiplying the whole number by the number in the denominator. This tells me that if I cut 7 wholes into 4 pieces, I would have 28 pieces. That now I can add it to this 3/4, which is what I did here. I had 3/4 and 28/4. I add that together and get 31, so 31/4. Now I'm ready to multiply. So we take 31/4 times 5 times 5. Now again, it's important to remember that these whole numbers have a denominator of 1 because they are 5 whole pieces. And when we have 1 as the denominator, that means that the number is whole. Now we have 31 over 4 times 5 over 1 times 5 over 1. In this case, I don't see anything that I can cross cancel. 31 is a prime number. 4 and 5 do not share any factors. They are also, 5 is also a prime number, so I know it won't share a factor with 4. So I'm going to go ahead and multiply. So I'm going to have 4 on the bottom, and then I need to multiply up here because I'm not very confident in what 31 times 5 would be. So now I have 5 times 1 and 5 times 15, and then I need to multiply that again by 5. So that is 5 times 5 gives me 25, 5 times 5 gives me 25, plus 2 gives me 7, I carry the 2 from the 20, and 5 times 1 gives me 5, plus 2 is 7. So we have 775/4, and those are inches, and I'm going to actually switch to this because writing inches in this shorthand with the 3 is going to be a little bit weird for me. So my final answer is 775/4. Now I know because 4 is never going to end, a number with a multiple or a factor of 4 is never going to end with a 5 in the ones place. But to be safe, I can always check and see if I can find a factor, a whole number factor. So I'll put 4 here. That's going to go in 1 time. That leaves 3. I bring down the 7. That is going to go in 9 times because 4 goes into 36. And bring down a 5. That is going to give me 15. So I know that's going to go in 3 times because 4 goes into 12. And that leaves me with a remainder of 3. So this does not go in. It is not a whole number. 4 is not a factor of 775. So I can then leave this as it is, or I can also turn it into a mixed number. Now I do see that I would have a remainder of 3 and 193 left. So I can write it as such. 193 3/4 inches cubed. So I can write my answer here in 2 different ways, as a mixed number or as an improper fraction or a mixed number.